Hey everybody, so this is the fourth 9 weeks review covering graphing, log, and exponential functions. Okay, so just real quick before we get started, I'm going to do just a little quick reminder down here. So exponential functions, exponential functions, you have two kinds. You have growth. Well, general form is y equals a times b to the x minus h plus k. All right, we have growth and we have decay. All right, so growth takes this general shape here, and decay takes this general shape here. Okay, so growth is when your base is bigger than 1. Decay is when your base is between 0 and 1. So that's just a little quick reminder there. So remember, defining characteristics. So the anchor point for these, for exponentials, are going to be found using h, a plus k, and these have horizontal asymptotes at y equals k. All right, so that is just a general reminder about exponentials. You guys have, you received like a half sheet when we did these back in March, and your teacher may or may not give you another one of those to have too as you study. So then the other was logarithms. Okay, so logarithms, the standard form for logarithms are y equals a times log base b of x minus h plus k. And again, we said we had log growth and decay. Same kind of deal. When b was bigger than 1, it was growth. When b was between 0 and 1, it was decay. And we said the general shape, because these are inverses, they're reflections over the line y equals x. You have this asymptote, and the general shape looks like this. And you have this asymptote here, and the general shape does this here for decay. All right, so your anchor point for this one, remember, is h plus 1, k, unless there was this special thing here. If there was a y-axis reflection, then it was h minus 1k. All right, so that was something you had to remember. And you had a vertical asymptote at x equals h for these. Okay, so exponentials had horizontal asymptotes and logarithms had vertical. So we got 5 questions that we're going to look at. So number 1, y equals log of x minus 5 plus 5. All right, so first thing here, hopefully you guys realize that when there's no base written out, it's understood to be a 10. Okay, so the base is bigger than 1, so it's going to be log growth, and log growth takes on this general shape here. Okay, so what do I need to know? So the asymptote for logarithms, you look at the inside here. Okay, so that says x minus 5. So the asymptote is going to be found when you solve that, and you get x equals 5. So you have a vertical asymptote here at 5. So we do know that. Okay. The y-intercept is what you get when you plug in a 0 for x. Well, if you try to plug in a 0 for x, you end up with log of negative 5. And remember, that's not possible. Can't take the log of a negative. So there's actually going to be no y-intercept, which we could kind of figure too, because my asymptote's over here. The graph can't go through it, so there's going to be nothing over here on this side. Okay, so what's not listed and what you need to add is the anchor point. Okay, so we need the anchor point here. So we're going to find that. This is a logarithm. There's no reflection. Okay, so because there's no reflection, remember it's h plus 1k. All right, so this is h plus 1k. And the y-axis reflection would have been found inside here. X-axis is in the front, so there's neither of those. All right, so h is your horizontal shift, which is inside, and that's 5. It also matches your asymptote. So in this case, it's going to be 5 plus 1 for your anchor point, comma k, which is your vertical shift of, here's k back here, 5. So we're looking at 5 plus 1, comma 5, which would give me 6, 5. So I go back to 6, 5, and here's that point right here. So it's going to take this general shape. It's going to hug that asymptote. And there's my graph. So then it asks you to do the domain and the range. Okay, remember, domain is from the left to the right. So when I look, this graph starts on the left side at 5. And it goes over to the right to infinity. Dotted lines get parentheses, infinities get parentheses. Okay, and the range here, the range for logarithms, but from bottom to top, it's always all real numbers for logarithms for the range. Okay. All right, so let's just jump over to number 3 because 3 is a logarithm. All right, so again, the base here is understood to be 10. So it's going to be growth. All right. So it would originally, let me scroll this up here. Originally, it would take on this shape right here, right? But do you notice there's that negative in the front? That's an x-axis reflection. So it's going to take this growth and it's going to flip it down here. Okay? So that's what my final graph is going to look like right here. It's a reflected logarithm. All right, so let's start with the vertical asymptote. So I look in here, x minus 4, when I solve that, not sure why there we go, wouldn't move for me. So when I take that x minus 4 and go the opposite, my asymptote is going to be at x equals positive 4. So I go to positive 4. Okay. My anchor point, again, h plus 1, k. So in this case, h was 4 plus 1, and k, well, there's nothing back there. It's understood 0. So I get a 0. 4 plus 1 is 5, 0. So 5, 0 is here. And remember, originally it was growth, but there was the x-axis reflection, so it has to flip over the x-axis to give it this general shape. Y-intercept, again, is none, because if I plugged in a 0, I would get log of negative 4, and I can't do that. Domain is from the left to the right. We start at 4, and we go over to infinity. There's never going to be brackets for this because of the asymptotes. The range is bottom to top, always negative infinity to infinity for logarithms. Okay. All right, so number 2, going back now because this is going to be an exponential. Y equals 2 times e to the x minus 4. Okay, so this e is not a logarithm, okay? E is 2.17. So this is exponential, and the base here, so your base is e, which is approximately 2.17. So this is growth, okay? So exponential growth starts small, and then it curves up quickly, okay? So when I do my asymptote, remember, asymptote is y equals k for these. It's what's in the back here. So y equals negative 4 is your asymptote. So I start here, negative 4. Okay. The anchor point, again, is not listed, and we need that. Okay. So the anchor point here is hack. H, A plus K. Okay. So for this example, H, there's nothing going on up there with that X. So H is going to be 0. A is what's in the front. That's a 2 plus negative 4. So 2 minus 4. So we end up with 0, negative 2 for my anchor point, which is down here. All right. Well, 0, negative 2, that's also the y-intercept. Okay. So then I can just sketch the graph. It's a growth. So domain goes left to right. The domain for exponentials is always all real numbers, negative infinity to positive infinity. So it's flip-flopped. So domain is all real numbers for exponentials. Range is all real numbers for logarithms. So now the range this time is from the bottom to the top. Well, I'm starting at the bottom at 4. It's an asymptote, so it gets a dotted line in a parenthesis, and it goes up to positive infinity. Okay? All right, so there's 2 more. So these were actually graphing, and then we're filling in the characteristics. Okay? All right, so 41, or 4, I'm sorry. What used to be 41? ln. So remember, ln, hopefully you remember, ln is a logarithm with a base of e, and remember, e is about 2.17. It's a 1. So this is going to be a log growth. So this is log growth here. Okay? No reflections or anything. Okay? It's just an understood base of e. So here's your h. Here's your k. All right? So anchor point, remember, that's h plus 1 k. All right? So here your h is going to be negative 2 plus 1. Your k is 3. Remember, h goes opposite. So your anchor point is going to be negative 1, 3. And your asymptote this time is vertical because it's a logarithm, and it goes with h. So your asymptote's x equals negative 2. Okay, this number's the same, right? So negative 2 gets a vertical line. All right, your anchor point is negative 1, 3, which is here. All right, so I do actually need to figure out my y-intercept. I'm going to come down here. The y-intercept is what you get when you plug in a 0, right? So when I do that, I get ln of 0 plus 2 and then plus 3. So it's really ln of 2 plus 3. So you do that in your calculator. So ln 2, close the parenthesis, and then plus 3. You don't want the 3 in the parenthesis, and you end up getting approximately 3.7. All right, so I can plot that. So 0, 3.7, that's somewhere right over there. Well, that's kind of giving me a good idea, right? I knew this was log growth. It's going to hug, and it's going to curve this way. All right, so my domain, remember, goes left to right. Range goes bottom to top. All right, so I'm starting on the left side at negative 2, and it goes over all the way to infinity on the right. The range for logarithms is all real numbers. Everything gets covered from the bottom to the top. Okay? All right, so increasing and decreasing intervals. So it's not going to be both. It's either going to be growth or it's going to be decay. So what I always say to do is imagine you were a person standing on the left side. Always start at the left side. What would this person be doing? Would they be climbing up the hill or would they be falling down the hill? They're climbing, right? So decreasing is going to be none because they're climbing. Increasing is going to match the domain, negative 2 to infinity. Okay. All right, so left and right in behavior. So on the left side, you're hitting that wall. All right, so as x goes to negative infinity, that's the left. Negative infinity is over here to the left, right? As x goes to negative infinity, my y values keep getting closer and closer and closer to that wall at negative 2. Okay? And on the right, as x goes to positive infinity, x values go to positive infinity, my y values are just steady climbing up to positive infinity. All right, and number 5. All right, 3 times 1/2, x plus 2 minus 1. All right, this is exponential. Look at that, that's a 1/2 base. That's exponential decay with no reflections. So decay looks like this. All right, so I need a, h, and k, right? H comes from up here, negative 2. K is what's in the front, that's a 3. K is your vertical shift, negative 1. Anchor point, remember, h, a plus k. All right, so negative 2. And a was 3 minus 1. That's a 2. Negative 2, 2. So I got that. Negative 2, 2. I know that one. I also know my asymptote comes from back here in the back. Y. So exponential gets the y. Equals negative 1. All right. Now, y-intercept, we need to actually do that this time because my anchor point's not my y-intercept. So it's 3 times 1/2 to the 0 plus 2 power minus 1. Well, that's just going to be 3 times 1/2 squared minus 1. And you can plug, you can plug that in all at one time. So 3, parenthesis, 1/2, close the parenthesis, squared minus 1. And we get negative 0.25 for that one. So 0, negative 0.25 for that. Somewhere down here. Which makes sense because this graph's going to be doing this right here. Curve into the right. All right, domain left and right. All real numbers for exponential functions. Negative infinity to positive infinity. The range is what has the asymptote this time. We start at negative 1. And we go up to positive infinity. All right, increasing or decreasing? Well, hey, it's decay. It hasn't been flipped, so it's decay, so it's got to be decreasing. You would slide down the hill, right? So increasing is none. Decreasing, you're sliding down the hill, so you decrease over the domain. It always matches domain. Left in behavior. As x goes to negative infinity, y is going where? Well, that arrow is pointing up. It's going up high. And on the right, as x goes to positive infinity, x's go to positive infinity over here. Y is going flat, right? To negative 1. We need to go back. I messed up on number 4 on the logarithm. We need to go back. I messed up the in behavior. So get this down. That's a negative 1 right there. And I'm going to go back to number 5. We need to fix this. The left in behavior, x can't go to negative infinity. I was backwards. X can't go to negative infinity right there. X is actually going to negative 2. And y is going down to negative infinity. I got backwards and I just wasn't thinking. The x is hitting the wall, right? The y is going down. Okay? So on the logarithms, you can have a boundary at the x. On the exponentials, you have the boundary on the y. And they're inverses, so it would make sense that they go back and forth between the x and the y. Okay, I'm going to zoom out so you can see all of this on this page. If you need to pause right here so you can see it, then do that. And I'll go back. Here's the other page with some of these notes on here if you need to pause to look at that as well. Otherwise, that's logarithms and exponential graphs.